On this assignment, which is on page 200 of your textbook, you are going to look at these tables like you've done before, and some of them are representing linear functions and some are not. So you're going to decide which are linear and which are not linear. And you're going to, for linear functions, you're going to write the function as an equation. And for those that aren't a linear function, be able to explain why they're not. Now, I'm not asking for the explanation on this page, but in your own mind, in your own brain, be able to explain to yourself or to someone else why you know that if it's not a function, why not? All right? So I'm just going to do two. I'm not going to do them all. You're going to decide for yourself which are linear and which aren't. And then for the linear ones, we're going to write the equation, either in slope-intercept form or in point-slope form, depending on which seems like the better choice for what we're given. All right. So first things first, let's just look at this one. So looking here on the left-hand column of inputs, I see from 5 to 6 plus 1, 6 to 7 is plus 1, 7 to 8. These are all adding 1 to get from one term to the next. And here I notice that it goes plus 4, plus 5, plus 6. So since these are different increases, you decide what your conclusion is. Is this a linear relationship that's shown here or not linear? You decide. The next one, let's look at the next one. For the next one, we see, let's see, we're going from -2 to -1. That's adding 1. From -1 to 0 is adding 1. And from 0 to 1, these are all adding 1. We're increasing our inputs by 1 each time. That's consistent. Now let's look at our outputs. 8 to 5 it's decreasing by 3. 5 to 2, it's decreasing by 3. 2 to -1, it's decreasing by 3. So if you were going to express this as a slope, you could say that vertical change over horizontal change, right? So every time that our x, or our input, increases by 1, our output, or our y, decreases by 3. So a decrease of 3 on the vertical axis and an increase of 1 on the horizontal axis. And that slope simplifies to -3. I'll let you do that process for this table on your own. But this one, since we have a consistent increase between all the points, we know it's linear. So because it's linear, we are tasked with writing the equation. Let me get rid of some clutter here. So far what we know is that our slope is -3. Now, these two forms both have slope. So, because this right here, the m, that's slope. So if we choose this form of the equation, we still need to know what our b is, our y-intercept. If we choose this form for an equation, we have the slope. Now we need to know a point. that we can plug in the x-coordinate right here and the y-coordinate right here. So either one is fine. Let's just do them both, right? So it's pretty easy on this one. It's a really good example for either one. So we know our slope, -3. The part we need to know now, let's say we're using the slope-intercept form, we need to know the b, or the y-intercept. Now, important to remember is that on a graph, the y-intercept is always on the y-axis. So the y-intercept is always going to be somewhere on the y-axis. It could also be down here, right? The y-axis goes in both directions, positive and negative, but we know that our y-intercept is going to be on the y-axis. On the y-axis, x equals 0. So the y-intercept is when x equals 0, and check it out. We have that point where x equals 0. So we know that our y-intercept, that's supposed to be a b, our y-intercept is 2. That's where, on this function, the graph will cross the y-axis. It'll hit the y-axis at 2. All right, so now we've got everything that we need to write the equation in slope-intercept form. So y equals m, which is -3, x plus b, and our y-intercept, or our b, is 2. Done. Now, an equally correct second way to write an equation for this function is to use slope-intercept form. So let's do that way too, just so you've seen them both, right? In slope-intercept form, we have this format. It's right here, so you can look at it. We have y minus y1. I'm going to just leave a little space for, well, I'll write it down. Y minus y sub 1 equals the slope times x minus x sub 1. So what we're doing is just plugging in what we already know, or substituting what we already know. One thing we already know is we already know the slope. The slope is -3. So plug that in. Now we also have a whole bunch of points, because remember, it's point-slope form, so we need to know the slope and we need to know a point. But we have 5 points right here. We have this point, -2, 8. We have this point, -1, 5. We have the point 0, 2. We have the point 1, -1. You can choose any of the points. So just for kicks, I'm going to choose this point. But you could literally choose any of these points, or even any other point that's on the graph. So in this case, this is going to be my x, and in our equation, it's labeled as x sub 1. And this is going to be our y, or in our equation, it's labeled y sub 1. So now we just need to substitute it. Y sub 1 goes here, x sub 1 goes here. So x sub 1 is -1, y sub 1 is 5. Now, this is mathematically true, but remember what you know. A negative times a negative equals a positive, or a negative times a negative gives you a positive product. So these two negatives that are here, when they're multiplied, become positive. because writing writing x minus -1 is the same thing as saying you'll have a parentheses here, so it's not confusing looking. And remember, when you have a number and there's something right next to it, like here, there's an invisible 1 next to this subtraction sign. So this 1, you can't see it, but you can now because I wrote it. But this is -1 times -1. So that becomes x plus 1, because -1 times -1 equals +1. So this is your final answer. Now, interestingly, if you wanted to follow up on this, you could change this form into the equation that we had before when we wrote it in point-slope form. You could just do algebra on it and you would see that they're equivalent. But that's it for now. Thank you.